now I think we do have a highlight that's really worth rejoining here, and that's the keynote from Wolfgang Prinz. So I basically remember about 12 months ago how little I knew about blockchain, and actually I didn't know that it is much more than just crypto coins. And then I found some YouTube clips from Wolfgang and learned a lot. So I'm very happy that he accepted our invitation and will prepare us now for the next session, which will then be dedicated on blockchain applications in health. So the floor is yours.
Yeah, thank you very much for the very nice introduction. So you put up the limits high, so I need to somehow convince you now that blockchain is somehow interesting, probably also for you. And you say it's not just cryptos. Are there any crypto millionaires around or so, any crypto investors? You won't be afterwards. I mean, I'm not trying to convince you to buy any cryptos. We are doing research on this topic now since many years, and I forgot to buy at the beginning. So when we started to do investigate blockchain, in particular on Bitcoin, it was around 800 euros. And then we thought, well, that's probably just a hype. It's just a hype with 800 euros. And then later on, we bought for 50 euros or so. So we didn't become rich. Also, none of my colleagues. But we are doing a lot of very interesting research projects that are funded. And the weather is nice outside, so it really looks like this at the moment. You see on the left-hand side our castle. I'm coming from the Fraunhofer Institute for Applied Information Technology, which is located in St. Augustin, just across the Rhine, also on a small hill, and there is this nice old castle where we are not working in. I mean, that's just on the campus. This is just for representation, and beside that are the ugly buildings where we work. And on the right-hand side, you see the Blockchain Reallabor, which is a location that we just rented about a year ago, and that is funded by the local government to support digitization and the transformation within the area. You may have heard that this area from here going west is very much dedicated to coal mining, but this will stop in about 7 years. So there will be a big structural change, and there are a lot of investments now in digital projects, in new technologies, and really to employ people once we stop coal mining and coal and energy production based on coal. And this project is one of the many projects. And within this Reallabor, we have a lot of demonstrators, and that is where we are educating companies, where we do projects with companies to see how blockchain can help them. None of them really has to do with any blockchain or with any cryptos in the end. Yeah, you see a little bit about, that's the department that I'm heading. So we are doing blockchain, we are doing mixed reality, and we're also doing communication infrastructures. So somehow when we did this slide at the beginning of the year, we saw, well, that's also metaverse. Yeah? And we have a short look at the end also that augmented reality and blockchain is actually somehow the two ingredients also for the metaverse. That is also currently a big, big hype and where a lot of people are talking about. So let's go into some of the terms that are currently being discussed in the internet. And this is something where a lot of people are convinced of, that we are now moving towards a new generation of the internet, which is somehow called the Web 3. My colleague, who is more convinced about augmented reality than blockchain, he's always discussing that with me. And he said, well, Web 3, that was the internet that was promised us by Tim Berners-Lee, the semantic web, where we now have semantic in the information and where we can do inferral and other things on the web. And now the blockchain guys, they come along and say, well, no, Web 3, that's us. And I always tell him, well, that was Web 3.0. I mean, this is just Web 3. But the difference is actually in what people consider here as interesting is the point that in the 90s, we had the information economy. I mean, we started all with web browsers, and we had servers, but it was mainly reading. And then the platform economy came along, and then we could read and write. Yeah? So now we can edit web pages, we have Wikipedia. And the interesting thing is that also this changed the way we get our identities on the internet. And I think that's the most structural change. At the beginning, we had something like user ID and password. And nowadays, when you log into any of the services, they always offer you log in with Google, Facebook, Twitter, Instagram, LinkedIn, whatever. So these big platforms, they try to get your identity, or they provide your identity. I mean, if you consider what is your identity on the web, it's your email address, or it's your LinkedIn address, your URL. And this is now changing. With the new generation of the internet, that is not just allowing you to read or write something, but also to own something and to execute. So you can have now assets represented in algorithms, in data storage, and these assets can be clearly tracked to your identity. And you can execute something on these different assets. And these assets can be crypto coins, but it can be much more. It can be data, it can be pictures, it can be cars, it can be anything that can somehow be tokenized. And the difference is now that with these platforms, you don't have user ID and password, you have a wallet. And the wallet is not just something where you put in your coins. So you shouldn't confuse it with the normal wallet where you have put your coins in. This wallet is more or less the container of your keys that you use to identify yourself to these different services as the one who claims to be the owner of the assets. So these services, what they do is they contain some tokens, and they store with this token the address of the user they belong to. And when you claim these as yours, you have to provide the appropriate keys to do public and private key encryption and things like that to prove that this is you. This is not like in the old platforms where they say, this is Wolfgang Prinz and he owns that. This is somehow anonymous, not completely anonymous, but it's you who gets your own identity, and that can be the same identity for all the different services. The disadvantage is that if you lose your password, you ask the platform, may I get my password back? Can you please renew it? This is what we all do. Yeah, and we just click the link, password forgotten, and then we get a new link. Here, you are lost. If you forgot your keys that describe your identity, you're lost. They cannot be recovered. That's in the nature of the system, that the keys are so unique that you cannot recover them. And when you lose your wallet here, also the assets that are associated with the wallet are lost. And that's the reason why some people say, well, I have so many cryptos or anything somewhere on Bitcoin or in other cryptocurrencies, and I lost my keys and they are gone. And nobody can recover it. So that's the magic behind that. So you see, there is now something like a big trend going on where we get from Web 1 to Web 3. And as I claim that within this new internet, you can own something, you have assets that are clearly trackable to you. You may say, well, I have a bank account. Yeah, there I have my assets. Yeah, I have a bank number and they know how much money I have. But that is then provided to you by a service, and now we get to a new age of IT that supports that. Sorry, wrong button. So let's see how this blockchain technology works. And what I would like to do is to give you a short introduction in blockchain technology itself. And then later on, we look at several application examples, which are not directly from genomics or something like that, but from other areas, but we try to map them to your application area. If you look at this here, I mean, this is an old bookkeeping department. Yeah, you see a lot of different records, and you see the people working on them. Now, if you digitize that nowadays, what you do is you put all the records in a database, and you put all the people in the middle into an application system that is working on the database. And then we have SAP or Microsoft something or whatever. And this is what we all do. Obviously, we are not working alone. We are working in different supply chains. We are working in big corporation networks. We exchange a lot of information. Therefore, we need interfaces to the rest of the world. So all these different companies, they all have their own big bookkeeping services, their own way of storing the data. So we need interfaces between all of them. And the problem is that, yeah, we need interfaces. And these interfaces are sometimes buggy. They don't exchange all the data. And then we have all the litigation processes really to keep, well, what is the state of our general process? What is that we have exchanged? What are the assets? They store the assets in a different format than then. And with this, you own 5 assets, and with the other one, you own 6. It's all within the technology, somehow difficult to manage in this completely heterogeneous system. And then there is the solution coming along, which is the cloud. And the cloud tells you, well, give me all your data. I keep it for you. I keep all the interfaces between all the different services. And you just connect to me as the cloud. And I guarantee that you have a state where everybody can believe in. and on the other hand, you just have one interface, which makes it very easy. Well, the disadvantage, obviously, is that we somehow have this hook up into the cloud. I mean, everybody is now just using this cloud. They give you the address, and if you want to log in somewhere else, they say, oh, use my address, please. And somehow that's the danger. And I mean, there's a lot of discussion going on in Germany, but also in other countries, that we need to keep track of, that we need to own our data ourselves, that we need to associate the data with ourselves, and that we need a more decentralized way of organizing the data instead of putting everything in the cloud. And there were some people from industrial companies that said, we have lost somehow the battle around our social data, because that's all with Facebook and all the rest. That's already somewhere else. But for the industrial data, we need to keep our data ourselves. And that is now where more decentralized approaches come along, and some of them are actually then based on blockchain. So if we look now at some more transactions, so we go a little bit back now to money and crypto exchange. If you think about the fact who is actually securing your transactions in your bank account. Because you may say, well, why is he talking about crypto? I can exchange money. I mean, why does he tell us now you can have assets in the internet? Because I have my assets, I have a bank account, I do electronic banking. Yes, that's true, but you completely rely on the so-called intermediary. You rely on the Sparkasse, you rely on PayPal as the central server who is providing you all the services to exchange your assets, your money. And you completely rely on their IT, on their organizational processes, and you trust in them. You trust in their organization. Obviously, they do everything right, yeah? But principally speaking, they just could exchange your bank account to something else. Because they have the power, they can do it. And maybe you would recognize that, but they can do it because they have all the passwords, they are controlled, but they can technically do it. And then people thought, can we invent a system where this becomes impossible? That the records that are stored in our IT system are immutable, traceable, and cannot be changed. And that was then the idea of this so-called Satoshi Nakamoto. Nobody knows who it is. And he wrote a paper in 2008, which is called Bitcoin, a peer-to-peer electronic cash system. And in putting there the technology that we were using in 2008, that was the BlackBerry, mainly. Obama was still president of the United States, and the Olympic Games were in Beijing. And in this time, these guys, nobody really knows who it was, and whether it was just a group of people or who it is actually. They wrote this paper, and they didn't publish it in a journal. They didn't publish it at a big conference. They just published it as a white paper on a distribution list. And then people implemented it. And then at the beginning of 2009, the system was implemented, and that was the launch of the Bitcoin blockchain network. And at this time, you could buy Bitcoins for a few cents, yeah? And only a few people did. Now they are rich, and they don't need to study anymore or whatever. Now they can invest in other things. But that was the first step of the whole thing, and that is somehow the origin. And if we now go a little bit deeper in the technology, what did they actually propose? I said, well, with these platform providers, they give us a centralized intermediary service. They said, no, you completely have to replicate everything. We need a network. So replace the platform by a network. And actually what they do is peer-to-peer computing. Maybe in the former days you also exchanged some music by peer-to-peer computing, Napster and so on. Yeah, it's all what they actually somehow do there. It's based on these basic principles. The second step is that we need to replicate all the transaction data. The data is not with one central authority. It's completely replicated to all the different nodes in the network. And it's not stored as a normal database. It's stored in a special format, in so-called blocks, and these blocks are linked to each other, and each block contains a lot of different transactions. So if you do a bank transaction on crypto, or if you just store a certain kind of data there, this becomes a transaction, and the transactions are collected in the block. And when the block is full, then it's added to the list of blocks, and this adding is done in a very interesting way. It's not by connecting block number 5 to block number 4. It's done by connecting block number 5 to the content of block number 4, so-called content-based addressing. They don't have fixed addresses. They say, well, this block comes behind the block that has the following content. And this is done by using hash functions. And the interesting thing is that if you change the content of block number 4, the connection is lost. So that's one thing to ensure that it's immutable, because if someone is going around and changing the content of one block, the next block will not fit to the previous one. Because it's not addressing 4, it's addressing the content of number 4. The content has changed, and then block number 5 is pointing into nowhere. And everybody can easily detect that somebody is trying to manipulate the data. The next thing is now that we distribute all our transactions to the network. So it's now in the network, and you see, if we have a network that can be unstable, it has different speed within the network. So it may be the case that the network becomes inconsistent because some nodes know something that the other nodes don't know. You see, the transaction A to B10 or D to E20 is only known by a few nodes, not by everybody. So if everybody would now add the transactions to the transaction history, after 5 minutes we would have a completely unstable and inconsistent state. But we want to have a consistent state over the overall network. And for that reason, we need to determine who is now the one who is authorized to add a new block to the blockchain. And if you would do this now within this group here, we could look around and say, well, this is our network. Everybody of you is running a single server. And now I distribute hundreds of transactions. You put them into a block. And now we need to see who of you should be the one who is adding this block to the blockchain. And the idea would be the oldest, the youngest, the richest, the poorest, but that's deterministic. That's deterministic. That probably would always be the same, and that can somehow be forecasted. We need to do this in a completely arbitrary way. So we do something like a puzzle. Maybe the first one who is solving a very complex genomic problem would be the one. And that's actually somehow what is going around there. You need to solve a crypto puzzle, and the one who is solving the crypto puzzle gets the right to add a new block to the blockchain. And this crypto puzzle is actually, I mean, how do we achieve this? The crypto puzzle is actually then solved, and the owner and the person, or the node who is solving this crypto puzzle is adding then the new block to the blockchain together with the solution of the crypto puzzle, and then he is distributing this to all the different blocks, and they accept it because it solved the puzzle right, and then it starts over again. Again, we distributed all the different transactions, we collect them into a block, we try to solve the crypto puzzle, and the winner adds it to the blockchain. But there are thousands of nodes. Thousands of nodes are computing the crypto puzzle. Only one succeeds. 999 compute for nothing. And now you get an idea why it's so energy intensive. And the point is, why should all they do it? You get an incentive. You get the incentive of additional new cryptocurrency that you transfer to yourself somehow with this new block. And that's the reason why people invest in computing hardware to run this blockchain network and to make this all happen. No? So in the end, it's not just to be good or just to invent a new, very democratic system. It's business, very much business also behind that. And that's the reason why people run these networks. And the higher the crypto price, the more you actually get as an incentive. So that's somehow the magic behind all that. And now you may ask, but isn't that just a normal distributed database, what he is telling us? And it somehow is a distributed database, but there is a big difference. In a distributed database, you distribute data on different servers. That is what you do. But they trust each other. They all trust each other. And if you access it, you access the overall infrastructure. With a blockchain system, or a DLT, a distributed ledger technology, you access each node, and the nodes don't trust each other. These nodes, they can remain in Germany, Bavaria, North Korea, Japan, China, Russia, Ukraine, wherever they like. And you don't need to trust the owner of the node or the organizer of the node, because the IT system does not allow them to make any changes to the data, and it's immediately recognized. So the trust boundary is between the nodes, and you just access now one of the nodes, and nevertheless the nodes provide you an overall status that is believed by all the different people who are involved within the network. just a simple explanation that this new blockchain technology is not so new, and that is a so-called Telestick. Yeah, in German, it's so-called a Kerbholz. Yeah, and this Telestick was used in the medieval age as somehow a blockchain. And normally I explain it with two trade persons who is coming from Cologne and Düsseldorf. Yeah, normally they don't like each other. Yeah, Cologne and Düsseldorf, there's this rival in Germany between the two cities. Now imagine there are two trade persons, they are meeting at the market in summer, and they owe each other 2 Thaler. What they do is they take this wood and they put in the 2 marks, the 2 Thaler, and then they go away. But they separate the whole thing here in the middle, and these pieces only fit together in this certain situation. So after 1 year, they meet back. And if, for example, the person from Düsseldorf, obviously, since I'm from Cologne, it's the Düsseldorf who's the bad guy, just puts another mark into this piece of wood, the Köln guy would immediately recognize that because he didn't accept it. They didn't find consensus about this. Yeah, that's very simple proof of work, yeah, but they didn't find consensus, and therefore they can easily recognize if someone wants to cheat. And since they can be easily recognized, they don't cheat. So we had already blockchains in the medieval age. We have the shared data. We have a copy for partner A, partner B. It's easy somehow to build a duplicate of that. I mean, IT cryptography is much more complicated than just having this particular figure in the wood, but it's somehow an easy thing. But now you may say, well, that's somehow boring. We just have, in the end, a boring database or boring data storage. Where is the active part in it? And Bitcoin is actually like that, but then Ethereum came along, and Ethereum, the Vitalik Buterin, somehow the inventor of Ethereum blockchain, he said, well, if we can put data in the blockchain that is immutable, then we could also put code in the blockchain that becomes immutable. And these are the so-called smart contracts. So a smart contract is nothing else than a piece of program code that is living or somehow stored in the blockchain and that is executed under certain conditions. So when a certain condition becomes true, then this code is executed and then a certain thing happens, like a transaction. So, for example, if x is larger than y and z is smaller than 20, then A should transfer 20 euros. This can be your train is arriving late and you immediately get reimbursed because you somehow have a contract with the train company that you are reimbursed when the train is 1 hour late. Yeah? At the moment in Germany, we fill in paper forms. Yeah? So, but that is possible with that. Or you can store, for a tracing service, you have a special medicine, should not be above 0 degrees. Yeah? You have a sensor, and the sensor constantly reports it, and it puts it on a blockchain, which means when you open the parcel and you see all the tracks on the blockchain, you can trust that. Yeah, that nobody was able to change it later on. Yeah, just to put you some other kind of data because, oh, it was somehow over 10 degrees, but this costs so much money, just manipulate the data. It's impossible to do that with this kind of technology. And these smart contracts have nothing to do with contracts or business contracts. These are just very simple rules, but they can be very effective to do automation on top of the blockchain or within the blockchain. And therefore, the reason is now why blockchain? Well, I mean, you see, we can store data and information irreversible, immutable. We have business processes that are completely traceable and they can be automated. And for a company, we suddenly have the way to have secure transfer of value without the intermediary. We don't need PayPal. We just need the network that is being operated to run this particular blockchain. And therefore, I was talking about the internet number 3, Web 3. Some people say now it's the 4th generation because from information we go to services, we go to things, and now we have the internet of value. Yeah? That's also some of the more business talk of selling the whole story. So you now may think, well, sounds convincing, but I heard about this item that blockchain is an energy killer. Yeah? And that's true, somehow. There are blockchain implementations that are really a killer and that are somehow CO2 killer, in particular Bitcoin blockchain. And Ethereum was because recently they changed the way they achieve consensus about adding new data to the overall blockchain. And the point here is there is not the blockchain. Blockchain is a term that just describes that we have an infrastructure where we have immutable data and that we store data in a certain way. But actually what the inventors of the Bitcoin blockchain really did is that they said, there are a few IT concepts around, and if we combine them in a very clever way, we get a new infrastructure. What they did is they used distributed networks, peer-to-peer computing. We know it from Music Exchange, from Napster. Cryptography, public and private keys. You know it from sending around emails that you can sign. Software engineering, smart contracts. I mean, these are very simple programs. That's first lecture, computer science. Data structures, blockchain is nothing else than a list that is connected to each other. It's content address. That's first lecture, computer science. This is proof of work. Even that was not invented by them. That was invented by people who wanted to avoid email spamming. They said if you want to send an email, you need to show that you did work on the community. And only then you are allowed to send an email to a larger amount of people. And here they say, you need to solve a crypto puzzle, and then you are allowed to add data to our blockchain, to our consistent state that we all believe in. And they combined it in a very clever way into the Bitcoin blockchain. But that means that we can look at different data structures. That's the data structure of Bitcoin. Yeah? We have the blocks that are connected, and then we have a tree. In another one, like Hyperledger Fabric, we use a normal database. It's also possible. In Corda, we even have other kind of databases. In IOTA, we use directed graphs. Yeah? And here we use some kind of gossip network in Hashgraph. So people are now looking at the different concepts, and they tear it apart. They tear it apart and say, oh, no, instead of a blockchain data structure, we can use something different. Instead of the proof of work, we can use something different. And the consensus method as the proof of work is just one way of doing it. And you see, as a software, you can have Bitcoin, Ethereum, IOTA, Corda, Hyperledger. The most prominent are Bitcoin, Ethereum, and Hyperledger. But the governance for the whole thing, that's the important thing. With Bitcoin and Ethereum, they are there, they are out there. I mean, we have the networks out there. If we want to set up a network ourselves, we need to find a governance for that. Who of you would be willing now to run a node? Who has the computing power to do that? How do we organize that? How can you guarantee that your node is running? What kind of incentives can we pay for that? And that's the point around organizing the governance. And that's sometimes difficult to do. That's very often where blockchain projects fail. They have a good idea, but they're not really able to organize the network who is doing that. And within this network, then we can be completely private or we can be permissioned. Permissioned means we have a network, and if you want to become partner of the network, you have to ask. And then we add you to the network. But we do some kind of trust check on you, whether you are really running your computers well. Because we are not using proof of work, we're using another way. And if you have a completely public network, like Ethereum or like Bitcoin, then we don't need to do any proof trust on you. We just can add you to the network, and we are sure, because of the algorithms, you are not able to do any malfunction on the network. And you see what kind of consensus building is possible in there. The simple one, where we probably have just a very private network, where we trust each other, is just explicit validation nodes. So we just take him. Because he's so trustworthy, he's the one who is always adding data to the blockchain. And after a week, we choose you. And after a second week, it's you. Simple, high scalable, very performance, but we need to trust each other. Again, we have some kind of platform. Or we can do a lottery protocol. Yeah, we do some kind of lottery, hardware-based random number generation. Intel is working on that. Or we do a proof of stake, which means, okay, what you have to do is to provide a stake, in German a Bürgschaft, yeah? You have to provide a stake that you won't misbehave. So for example, if you own 1,000 Bitcoins, Bitcoin is not, let's say Ethereum, if you own 1,000 Ether, then you stake them, and that gives you the right to add the next block. And if you do anything wrong, the money is taken away. So you lose your stake. Therefore, you should be of interest that the blockchain is working correctly. So next block, another one puts the stake, another one puts the stake. So we don't have to do any strange computations. We just have to put our money into the pot, and then it remains there for a certain time until everything is clear that that you didn't manipulate the blockchain or did anything wrong, and then you get the money back. So nowadays you can also make money on staking, so you can rent your money to some pool who's then staking the money for becoming the next one who is doing this whole block stuff. And the last one is proof of work. That is about the crypto puzzle that I explained. So the design space, if you now consider to use a blockchain, is really about being permissioned. So we have our closed network, or unpermissioned. Do we just want to store transactions, just data, or do we want to have a logic-oriented? Do we want to have smart contracts? And you see there are blockchains like Bitcoin. It's transaction-oriented, no smart contracts. Ethereum, transaction-oriented plus smart contracts. You really can implement a business logic within these kind of blockchains. And you see, under Ethereum, I put EVM, Ethereum Virtual Machine. That's somehow the logic that is able to implement the smart contracts. You can also have Ethereum running in a permissioned network. That is what we do in a lot of research projects. We don't put our data in a public network. We run a permissioned network of selected partners, and we use Ethereum, which is then called Quorum. Yeah, it somehow has been implemented by some nice guys, yeah, who said, well, we take Ethereum, the code, but we don't have all the Ether stuff and the crypto stuff. We just have all the capabilities of the blockchain, and we put it there, and also Hyperledger Fabric. So these are the ones who are mainly used in business environments. There are also many others, but these are the ones who are mainly used. So, skip this. And then the point is, do we have a world of blockchains? Yes, we have. We have now a number of blockchains running. And these blockchains are probably first-level blockchains like Bitcoin and Ethereum, and second-level blockchains like, what is it? Name comes later on. And which are somehow hooked up to this blockchain. These blockchains, the second-level blockchains, they provide low transaction fees, scalability, but they are running in a somehow private network. And then you may say, well, do I trust this private network? And what they say is, what we do is that every 1,000 transactions, we put somehow a hash code, something like a proof signature, into the public blockchain so that you can always prove whether our blockchain is running correctly. So they are hooking up to each other. So now we get a network of these different blockchains. So we have now manifold design decisions that we can take, and therefore blockchain becomes more and more applicable to different applications. Is your application blockchain ready? Is it good to have your application on the blockchain? We developed a use case identification framework and canvas that you can fill in. So you have to think about what is the data, what are my partners, what can I automate, what are the values and rights? And this is not giving an answer yes or no. This is not a decision tree. It's somehow a way to organize a discussion with people to understand whether the use case is blockchain applicable. And we can now go to some use cases which are blockchain applicable. The first one is a very simple one, which is actually certificates and certification. Yeah, your certificates that you get from university. And we all know we have a lot of doctors who have never been a doctor. We have pilots who never learned how to fly a plane, but they can do it anyhow. And the idea is, can we get rid of all these paper documents? And there you see the certificate that you get at Fraunhofer when you visited a certain course. And what we do there is now that we sign it. And now it's being signed digitally and also put on the blockchain. Not the complete document, but the hash. Somehow the fingerprint of the document is now stored on the blockchain. And that information is now also recorded within this QR code. So now you can print it. Yeah, everybody wants to have a printed certificate still. You print it, and then you just take your QR code. You just check the QR code, and then you see that this particular certificate has been registered on the blockchain. And you see the data, or parts of the data, and you can see whether this is something what you see here on the web page or on the paper corresponds to what other people put on the blockchain. That's the simple, lowest hanging fruit of doing blockchain applications, putting a document as a fingerprint on the blockchain, and then later on you can prove it. You see it here. So you get the document, yeah, and you put it here on the web page, and it's now being hashed again. So we take the document, we compute the hash, the fingerprint, check if the fingerprint is stored on the blockchain. Yes, that's original. No, somebody manipulated it. Not on the blockchain, but the document that you see here on the desktop. It's a similar way as you have with the COVID test, but this is not running on a blockchain. They just do it with public and private key infrastructures. At the beginning, there was also the idea to put it on the blockchain, but there was a big discussion also about that. And here you see how it works. You see we have all the different certificates, and actually what we put on the blockchain is just the light blue in the middle. That's the certificate store that stores the fingerprints, nothing else. And everybody can now check if the fingerprint of a certain document is located there. What I normally do is if you would like to take the slides, I just put the slides, the hash of the slides, the fingerprint on the blockchain, then I send it to you, and later on you just check whether I've sent you the original slides or not. That's the easiest way. But we can do more interesting stuff with that. We can do process auditing. And what you see here are two machines, and they produce something. Let's say very complex medical equipment. And what you, as the orderer of this equipment, want to do is that you say, please produce these things in a certain quality with certain data. So this is the contract that we have. Please produce thousands of these, and they must conform to this particular kind of tolerances and data. So this is what we put in the smart contract. Now the machine is producing products, and it has a lot of sensors. It's telling the sensor value to the smart contract. The smart contract compares the sensor value with the intervals that I provided as the orderer and checks, is that correct or not correct? If it's correct, it gets a certificate. And later on, when somebody is buying this from me, everybody can check whether this has been produced according to the standards that have been set. So we don't need any people who come along once a year to check if the machine is operating correctly or somebody's just observing it. This can be done completely automatic. And this is something that we can also show as a lot of different demonstrators, and that's some of the second stuff, not just certificates, but machine data for products. And then we have a digital twin of products in the blockchain. And people, I mean, you could do it with cars, and Mercedes-Benz, what they did is, they did an investigation and they said, well, if you sell a car that really has a proven track record, you can sell it for 2,000 to 3,000 euros more than a car that doesn't have that track record, which means that becomes valuable suddenly. The next thing is that track and trace. If we now go into a value chain, what we see now is that we have data currently in a lot of different silos. And at the end, the retail in the whole supply chain dominates the intercompany traceability. The retailer is the one who has the most data. He knows most of the whole thing. The producer knows nothing. He's selling something away. He's not knowing what's happening to his products. And the point is now that we probably can just provide data on how our products should be used. So we are discussing that with the Ministry of Farming here in Germany, because farmers, they probably want to sell. If you want to use this kind of milk, if you want to use this kind of corn or whatever, and this is bio-produced, and if you want to sell it, it has to be processed in a certain way, and you have to prove that you do this. So you somehow provide a disposition about the storage conditions, about the processing, and maybe even, oh sorry, that's not translated, maybe even later on in the presentation, how it should be presented in the store. And that can be somehow prescribed, and the different organizations, they have to prove that they did it, and then the smart contract at the end provides a certain certificate. So the smart contract digitizes really rules for product treatment. You can also put it on medical data or medical products and the rest. So there are new opportunities to put also now the people in front of the whole supply chain into more power for how their products actually should be used and should be transferred. Oops, sorry. The next one is that about tokenization, NFTs. I mean, there will later be a talk about it. Just to prepare the ground, tokens is actually the digital representation of a real-world asset on a blockchain. It's the fingerprint that we normally take. We are not putting the image of Mona Lisa on the blockchain. We take the fingerprint, which is normally a large, very cryptographic number, but it's uniquely identifying this particular image. And since this now becomes unique, we somehow can own it, we can sell it. And that's now behind all the stuff that you see on the internet, on newspapers. You see these bored apes. The first picture was sold for $69 million. Somehow crazy, not the picture, just the fingerprint as an NFT on a blockchain. That raised the whole hype around that. But we can use it for many more things, because somehow now, since digital objects are easily copyable, so you can be easily copied, now it's a digital asset that can be assigned to a certain person, and we can say, this is the person who owns that particular digital asset. And a lot of different things are possible with that. For example, your data. I mean, you all produce a lot of data. And by putting this data, for example, now somewhere on on a cloud service, you could also put the fingerprint of the data on a blockchain, which is associated with your identity, and then you can easily claim that this data has been put on the cloud by me. That's my data. So you somehow produce an NFT instead of a Bored Ape. Yeah, you produce a nice, interesting NFT that belongs to your data. So we can do it with documents, certificates, testimonies, data. We can do it with machine and equipment. So we put cars as a token on the blockchain, or even commodities. Where could this go to? We could say, well, now we can even have money that is programmable. That can be socially explosive, but it could be something like pocket money. Yeah, how often do we do this? Yeah, we give our children money and we say, but don't spend it on comics and fast food. Go and buy a book. What we can do is now that we can somehow tag or color the money, because it's crypto money, it has associated a smart contract, yeah, and the poor guy, normally he's actually using the 10 euros directly for buying some fast food at McDonald's, but if he would like to pay with the cryptocurrency at McDonald's, the transaction wouldn't work, because the smart contract says, no, the seller has to prove that he is not fast food and not comics. He has to prove that it's a bookstore. He has to provide an identity as a bookstore, otherwise I'm not going to transfer myself. So, and you can have a lot of different ideas. Yeah? 20% of my donation should be used for administrative services, which means 80% should really come to the people. Only books can be purchased. We are doing a lot of research projects. And these research projects, we have 10% is for funding, for travel, 80% is for work labor. And then later on, the auditors come and they prove what we are doing could all be done automatically. Yeah? Or the inheritance must be paid to my granddaughter. These rules can now be put on a blockchain. These are ideas. I have a colleague who's doing a PhD on this whole topic. Maybe these ideas sometimes go too far, but this is something that becomes possible with this technology. And I think the last thing that is really interesting is that of identity management. There are very interesting standards around, like decentralized identities and verifiable credentials. They are proposed by W3C, so by the World Wide Web Consortia. And a lot of projects are currently going on in Europe, in Germany, to develop infrastructures for a self-sovereign identity, which means that your identity is not provided by Facebook or even T-Online as an email address or whatever. You create your own digital identity, which is then somehow confirmed, maybe by a bank or by the passport service or whatever, and this identity is then being used to identify yourself to different services. So this is a whole flip over. You have a wallet in which you have your identity information, and if you want to register for something, you just show your wallet to get in. Similar to the COVID pass. Yeah? You've shown it and then you get into the restaurant, and this is now completely different. It's based on blockchain, so we have this kind of wallet-based identity. And I think this will quite change a lot in thinking on how we use services, a lot of thinking in what is an identity, how many identities do we have? Maybe we have one identity that we use for business, we have one identity that we use for online gaming. All that is possible. But you are the only one who's keeping track of that, and we are not giving everything then away to some kind of platform providers. It's also criticized. There are some people in Germany who criticize it heavily, this new approach. But on the other hand, the government is investing millions in this approach. Europe is investing millions into that. And this could really be a rule changer in the next years, if it really is being adopted, as many of the technological things. Whereas the blockchain is actually down there, this bottom of the verifiable data registry, and it happens like an issuer is providing, or you provide your own identity, and then an issuer provides you a credential, which is not stored on the blockchain. So it's different to the approach I've shown at the beginning. And then you give this credential to someone else. Hey, I have a driver license, and then the verifier just checks if you have a valid driver license. And that's the big difference. Nowadays, if you go to a car rental company, they ask you for your driver license. They see your old picture, yeah? They see your birth date, they see a lot of other information. So you actually give them a lot of information. And very often they take a copy. With this system, they only get the information, yes, you own a driver license, not more. And that in a very trusted way. So that's also very interesting on what's happening there. The question is now, which blockchain is appropriate for me? Let's say you are now convinced and say, let's do a blockchain project for our genome data and let's try to exchange it. Let's build a data marketplace for that. A lot of people are thinking about it, and I think we hear later on. Well, it really depends. There is no clear answer what kind of blockchain you should use. I mean, we have all the different implementations here, but I can give you a recommendation. Look at Blocksberg. Blocksberg is actually the blockchain for the research community. It has been founded by the Max Planck Gesellschaft in Munich, and they are running now a worldwide network of hundreds of nodes. Everybody can become a member. It's actually based on Ethereum, and you can use this one to do experiments, to deploy your own application. And for example, the guys who did this at Max Planck were the digital library department. What they said is that we wanted to provide the people of the Max Planck Society, we wanted to provide them a digital service to claim their data. Yeah? To put data somewhere on the web and to claim that it's their data, to register it somehow in a blockchain with the appropriate fingerprint. So that was their original idea, and appropriate services are offered there. So Blocksberg is really something to look for the research community, and they're now building an association of it that should be founded now within the end of this month on Cyprus. And we from Fraunhofer, we also support this whole initiative because it's very interesting. So with this, I would like to come to the end. I hope I could somehow get you into the deep stuff of blockchain so that you know a little bit on what's actually going on there, and to show you some application examples. And maybe you are now curious to visit us. You can visit us either in the castle over the other side of the Rhine, or in the Blockchain Reallabor, where you can give you a lot of different demonstrations of the applications I've shown here, and where we can also workshops on how we can put your application on the blockchain. But now I'm open to questions. Thank you very much.
Yeah, thanks a lot, Wolfgang. There is already a question from Anna. Can someone pass the microphone to you?
Thank you. Okay. Oh, well. That was an amazing presentation. I loved it, although I know most of the things. It was so fun. I'm talking about the Blocksberg chain. You said it's running on the EVM.
Yeah.
So is there a bridge already where you can transfer to Ethereum, like from Gnosis to Ethereum, or how's it working?
Probably would use Polkadot for doing this. I'm not sure if maybe someone did it already. But it's really all these smart contracts that run on Ethereum, you can just deploy them without any problems. So this is what we do. Normally when we do projects with students, they normally run it first on their computer with Grenache and Truffle. Then we put it on our own local network, and then maybe later on also on Blocksberg. And if there is any bridge to Ethereum, I don't know. Okay. Maybe someone did it already as a PhD or master thesis.
Cool. What is your personal favorite application on the blockchain? My last question. Thank you so much.
The simple one is really the simple, for me, when I talk to industry, the whole putting certificates on the blockchain, making tokens out of it. I think this whole tokenization is very interesting. What is currently a door opener with industry is NFTs, yeah, because there you talk to marketing, yeah, somehow, and they are very much in favor of that, and then you somehow get the step into the door. I think what we are trying to do is to put this building on the left as a DAO. Yeah, I mean, we also have an association with this, and this is also another term, a decentralized autonomous organization. So it's somehow an organization that is completely organizing itself or being supported by blockchain smart contracts. So what we are doing is we are paying our coffee with cryptos. We open the doors with NFTs. We do voting with, on the blockchain and all the rest. So we somehow have our administration or the running of the organization is supported by blockchain means. I think that's somehow the way it will go.
Yeah. Okay, can you pass it on to...
Thank you. Yeah, thanks for this very insightful talk. I have a question regarding to something you mentioned at the very beginning, that the security of the entire process is based on the fact that the block uses a hash function to the content of the previous block, correct?
That's one factor, many others. That's one part of it, yeah.
Okay, because my concern, if you want to call it, is that most of hash functions are not injective, so that you have a very small probability of mapping to the same, right? And that would be a...
That's the danger, yeah. But yeah. The point is finding the other value or finding the other content that has the same hash value is almost impossible. And I mean, there is another argument. You could argue, well, but if I change the content of block number 3, then I compute later on a new hash for block number 4, and so on and so forth. So I just changed the whole chain. But this is not possible because part of that is also the solution of the crypto puzzle. And that takes time to solve. Yeah, so you cannot solve that immediately. So it takes time to solve that. Then you need to solve the crypto puzzle for the next block, for the next block. In the meantime, the whole network is already far away. They have added already 10 new blocks, and you will always lose against that. That makes proof of work so applicable really for public networks. Yeah? But with the proof of stake now in Ethereum, they managed now to run Ethereum in a secure way with proof of stake. And there the point is that, well, you lose all your money if you misbehave.
Yeah.
And you really have to stake a lot. And I just saw that German Telekom is also now running a validation node within the Ethereum network. So it now reached a big German old-fashioned company somehow.
Thank you.
Okay, Benim, quick question.
A quick question. Thanks for the very beautiful talk. A question about the hypothetical but possible future where quantum computers to their full capacity are built. Would you consider that a threat to all blockchains?
It is, yeah. I mean, the reason is that with quantum computing, you can easily solve all the public and private key problems. You can easily find a hash, yeah, or the input data for a hash to produce 2 hashes, to produce the same hash with 2 input data. Easily possible. Yes, blockchain is in danger then, but all our security services are even in danger. I mean, this is not newly invented technology. It's a cool combination of existing technology. And all our security services are based on the same functions. Yeah? So it means if we really have quantum computing, forget about any security on the net and with all the secret services. Yeah? We can read everything, more or less, because then we can hack them also. The point here is that one argument is this, and one people say, okay, but then we just change all the data on the blockchain, yeah? And we just we recombine it, but other people then say, no, we can't do it because it's the blockchain, yeah? It shouldn't be changed. I think the same way that quantum computing progresses, the same way cryptography progresses. And it's always a race. And I think in the end, they will be somehow in parallel.
Wolfgang, could you comment on the trilemma of Web3 with scaling, decentralization, and what's the third?
The other one, Web 3.0?
Security. Well, what is it? Decentralization, scalability, and security.
Yeah. There's no, I mean, some people see, now, why shouldn't there be a dilemma? I mean, it's somehow, well, okay, I mean, blockchain is not yet scalable, fully scalable. Yeah, I mean, the idea that we run the whole financial services on a blockchain cannot yet become true. I mean, there are millions of transactions per second, and blockchain can do thousands of transactions per second. But the idea very often is that we have this kind of layered approach, yeah, where we have the first level blockchains, which may be slow, but we have then side networks, which are much faster. And they are not that secure, but they somehow borrow the security from the first level networks by hooking themselves up to these networks. So if someone is trying to misbehave on these side networks, you can easily identify it. That's one thing. If I understood your question right, where you see the dilemma.
No, I think you did. My understanding is that it's easy to push 2 of the problems, but then the remaining one becomes more difficult.
I see. Yeah, that's right. Yeah, that's right. Yeah, I just remember a colleague of mine just also explained this. He's actually a lawyer, and he also explained this dilemma to us. Yeah, but I'm not that deep in this deep security stuff to answer that.
Yeah. Okay. I really want to make sure that we get ready for the next session. So, Thomas, do you think you would still use a telestick, or would you switch to blockchain? Yeah, I mean you. You are an old AGD member.
Extremely reluctant to switch.
You would be reluctant?
Yes.
Even after that hour?
Yes, I would be
Just
reluctant.
because of this hour.
I would be reluctant. What you didn't lose a word about, but maybe it's implicit in about the errors or possibilities for falsification, for cheating, just take a copy of the document with the code. I mean, that you pass on to somebody else this document, and this person uses this document in your name, and if it's a driver's license or anything, a passport or something, then the car rental company will not ask anything else, because they don't ask for the date of birth and so on, and they say, okay, the person who's presenting this document, the identity is not proven with this.
No, right. In the simple example, yes, but normally this check also involves an identity check of yourself. So it also shows an image of yourself, and even in the worst case, they may even ask you for your passport. Yeah. So you don't need to show them your identity card, but you show them the passport. But normally they also contain images of yourself within the certificate. Yeah. But how do you do this nowadays? I mean, when you prove your identity, you show people your passport. Yeah. And I mean, to similar-looking people, they can easily exchange the passport. I mean, what did my son do? I mean, he faked all his student cards to get into the discotheque and into clubs. Yeah, or a lot of people take the passports of their older brothers to get in there. I mean, with the real-world documents, there is no security. It's the same level of security. Yeah. Obviously, okay, people say, if I lose my smartphone, yeah, and if I lose it together with my PIN, then people own my identity. There is a danger in that. Definitely, there is a danger in that. And I think the problem is that we really have to educate people about the processes, and that you really need to you have to keep it very secure in the end. But the point is here the same. I mean, these certificates include pictures. They include, for example, biometric data that you have to check to do that. Yeah. I mean, it's the same with the COVID pass. Yeah, I mean, which restaurant actually checked your identity? Here it is. Okay, go in. Yeah. I mean, there are a lot of other problems with that in the real world.
Yeah. We have 2 more hours. I will ask you the same question afterwards again. Maybe.
I mean, one thing is that I just mentioned, when you have a sensor that is tracking the temperature of the fish or whatever, the biggest problem is if the sensor is correct. I mean, the blockchain does not provide the truth. Yeah, I always say, well, if Donald Trump would put all his tweets on the blockchain, they wouldn't become true. But in 10 years' time, we could tell him what kind of things he was showing. I mean, we can still trace it back to him. Blockchain just stores the data that you put on the blockchain in an immutable way. Whether it's true, that's not the consensus. Very often you read papers, well, the consensus algorithm decides about the trust of the data. That's rubbish. I mean, rubbish in, rubbish out. That's also true for the blockchain.
Okay, I'm super happy that we can't answer all the questions now, because we can ask them later in the panel discussion, right? I just would like to ask you one last question. So you brought the example with the comics and the fast food. So what's the smart contract you would like to have with your health insurance? Is it maybe drugs that you can only buy if you have the relevant SNP in your genome, so that this drug actually works? Or what would you dream of?
Difficult to say. I'm not sure if I would put this really on a blockchain, but I think the point here is that maybe if there are some regulations, or if I'm reacting not good to some kind of medicine, yeah, that, for example, when a prescription comes in, that maybe the smart contract reacts on that. That could be something. But I think for that we don't need a smart contract in the end. You can do this with a lot of other IT systems. Yeah. So maybe you ask me in 2 hours' time to answer that correctly. I mean, really, although I'm somehow think it's a great, nice technology, the blockchain is not the solution for everything. I mean, a lot of IT systems are good, and I have some other points later on for the panel discussion.
No, thanks a lot. And I think most of the 4 speakers in the next session do agree with you that blockchain is not the solution to every problem.
No.
Okay, thanks again.
Thank you.